It talks about prenatal care. Prenatal care is the care that a baby is given while it's in the womb of a mother. And usually moms will, after they, have a sense that they're pregnant, they'll go in and see a doctor, and the doctor will put them on maybe some vitamins or a diet, or, make sure everything is going okay. They'll measure the baby's pulse and heart rate and all of that. And they'll schedule about a meeting every month during the 9 months that the baby is carried to just check the mom. And they recommend that you go to see your doctor within the first 3 months. So, but here's our one sample, and we have new moms. So who have given birth. And that's the population. So what we do is we just take a sample. And for this sample, we can go ahead and do the row and column totals. All right, so these three numbers add up to 826, and those add up to 53, and those add up to 60. And over here, the number in the first row adds up to 652, and 83, and 204. So if you add those numbers, you get a total of 939. So up here, we have a sample size of 939. And they have two pieces of data on every one of those 939 new moms. And they said, when did you seek prenatal care for your baby? Was it within the first 3 months? Or did you seek your first appointment from 3 to 5 months? Or did it take you longer than 5 months, from 5 months until birth, before you actually went to a doctor and had the prenatal care? Now, the other variable here is whether the pregnancy was intended or not intended or mistimed. So you can see that of our 939, most of the pregnancies that led to the birth of a baby were intended. The moms intended to get pregnant, intended to have the baby. Well, there's another group of new mothers where the baby was not intended, like the whoopsie, right? So they got pregnant and they really didn't intend to get pregnant. And there were 83 in our sample. And then they also classified some of the births as mistimed. So these were moms that, they knew at some point that they wanted to get pregnant. They were in the relationship that they wanted to be in to get pregnant, but they wanted to wait for a couple of years, and then they got pregnant. So they wanted to have the baby, but it was just not the right time. And they call those mistimed. Okay, so overwhelmingly, the babies were intended or mistimed, and then in some cases untimed. So the question is there a relationship between the wantedness of the pregnancy and the number of months that it took before the mom went to seek prenatal care for the baby? So that's the scenario. Now let's go through the 5 steps. All right, I'll start this down here. Now, what we really should do in each case is, and this is a good one here, because if we want to know if there's a difference, then we should calculate the conditional proportions. That's going to tell us, that's going to enable us to write our conclusion at the end. Is there a difference between these 3 types of moms? And so the wantedness of pregnancy, we're going to call this the independent variable. And since this variable is the independent variable, we're going to divide by the row totals in this case. So we're going to divide all of these by 652, everything in the first row. We're going to divide everything in the second row by 83. And then we're going to calculate these proportions you know, and then convert them into percentages just so we can compare the three different types of pregnancy, wantedness of pregnancies. All right, I don't have these calculated, so I'm just going to go ahead and do them for you here. And 33 divided by 652. All right, so I'll write with a different color here. 0.9, I'll call it 10, and then this one is 0.040, and this one is 0.051. Now I'm going to do those three and divide each one by 83. And we get 0.771, 0.096, and 0.133. And continuing to the last row where we divide by 204. We get 0.828, 0.093, and 0.078. All right, now here's what we can see with these conditional proportions. We can see that when the baby was intended, when the pregnancy was intended, 91% of the time, the mother consulted a doctor in less than 3 months. When the baby was unintended, the mother sought care for the baby less than 3 months, only 77% of the time. So you can see there's a big 14% difference between these two. When the baby is intended, the mother is more likely to seek natal care, prenatal care early. So there's a big, 14 percentage point difference between these two. So there's a difference that we observe. Over here, in this middle range, only 4% of the time did the pregnancy that was intended, did the mother seek prenatal care from 3 to 5 months, where these numbers here are twice as large as that. And then I want to go to this one over here, particularly just comparing these two here. When the baby was unintended, the whoopsie, it took the mothers more than 5 months to seek prenatal care there. Now, there could be a lot of variables that might explain that. Maybe these were younger moms that, maybe even teenagers that didn't want to share that information with anyone and just kind of waited and waited and waited until it got so obvious that, hey, you're pregnant, you should go see a doctor. So those variables are not accounted for in here, but you can still see that it's over 2 times as, the rate, more than that, where unintended moms wait for more than 5 months to seek prenatal care, whereas if the baby was intended, that happens only 5.1% of the time. So calculating these conditional proportions is where you're going to see the differences on the independent variable, and it's where the topic of section 4.4, calculating these conditional proportions. All right, we have enough of the background now. Let's go ahead and write the hypotheses. All right, so the wantedness of pregnancy is one variable, and the months pregnant before prenatal care begins, that's the other variable. So here, we're just going to say variable 1 and variable 2 are independent. So I'll write it out that way. Wantedness of pregnancy, or whatever the first variable is, and months pregnant before natal care begins, prenatal care begins. And then here's the last word, independent. Knowledge of one did not give us any information or change the probability of the other. Another way of saying that is that the two variables are not related in any way. The null hypothesis is always a statement that there is no difference. In this case, there's no relationship. All right, and then the alternative would be kind of the competing hypothesis to that. And that would be that the wantedness of pregnancy, again, we're just going to say the two variables are dependent rather than independent. And months pregnant before prenatal care begins, all right, are dependent. And what that means is that there is a relationship between the two variables. Now, we suspect that there is a relationship between the two variables because we see these big differences here, and we see the big differences here between intended and unintended. Usually, the alternative hypothesis is the claim. And if we had to, we would come up here and we would actually see that. All right, maybe it's down here in D. Test whether prenatal care and wantedness of pregnancy are independent. All right, so maybe because they said are independent, we'd have to put the claim up here. But usually it's the alternative hypothesis. And then the level of significance is right there. Okay, now what I'm about to do do step 3, which is to gather the evidence to calculate the test statistic and the p-value, is something new. What we have to do is we have to take this matrix up here and we have to put it, it's going to be our observed frequencies. And we need to put these observed frequencies into, all right, so the O's of our test statistic, we're going to put those in this matrix A. Now, the observed frequencies always come from our sample up here. So we're going to go put these numbers, 593, 26, 33, 64, 8, 11, 169, 19, 16. It turns out that we have to go put these numbers into this matrix. And then we have this other matrix, the expected values in our test statistic formula. That would be the E, and all of our problems, we're going to put those expected values in B. Now we have to calculate these, and let me bring back this other sheet here. The expected value in each case is the row total times the column total divided by the total sample size, the table total. So for our example, for this entry here, which is right here, we would take the row total, 652, and multiply that by the column total, which is 826, and then divide by the table total, which is the 939. We would have to do that 9 times to get all 9 of those expected values. So let me just calculate this first one for you. And there it is. So that number is approximately 573.533. 0.37. I'll just round it to 3 decimal places. And we would have to do that for all of these other entries to find the expected values. And then what we do to calculate our test statistic is we take the difference between the observed value in this position and the expected value, square it to make it positive, and then divide it by the expected value. And then we add fractions, 9 different fractions in this case. But let me show you what happens here. We'll wait on calculating the rest of those. This matrix here has 3 rows. And this matrix here has 3 columns. And so it is a 3 by 3 matrix. Now, for this test, saw the critical values. We have a degrees of freedom. And the degrees of freedom is always calculated by taking the number of rows, subtracting 1, and number of columns, subtracting 1, and then multiplying those 2 numbers together. So in our example, we have 3 rows and 3 columns. So we're going to multiply 3 minus 1 times 3 minus 1, or the degrees of freedom for this test is going to be 4. So if we ever use a classical approach, we need to know this number. All right, I'm going to take you through the steps of how you calculate this test statistic. I will refer you to these notes that will be in your lecture notes that you can follow. The first thing you want to do is to enter your observed values in matrix A. So let me show you how to do that. Right down here, above x to the -1 key, you're going to see matrix. That's where you want to go. It's in blue, so you have to hit the blue key first. So I'll hit second and then x to the -1. And this is what you'll see. I have lots of matrices in here. You may have only 1 or maybe none. But to enter in those 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers, we need to go over to edit. This is analogous to the stats menu. When we select the edit menu, that means we're going to edit our data list. That means enter data. Same idea here. If we edit a matrix, and I'm just going to hit enter here, you can see this matrix 3 by 4 is there. Now we need a 3 by 3 matrix. So we're going to hit the first number, 3, and then hit enter. And then we're going to hit the second number, 3, and then enter. And notice the matrix changes to a 3 by 3. So looks like I already have the numbers in there. If you didn't have the numbers in there, then you would just type them starting with 593 and then hit enter. And then the data values are entered row by row. So hit 26 and then enter, 33 and then enter. And as soon as you do that, it will go back down to the next row. 64 enter, 8 enter, 11 enter, and so on till you get the whole thing. Now, after you get everything entered in here, then you want to quit out of this screen, because it's unlike the stats screen where you can just go right to other commands from there. In this particular case, you have to quit out of here. So there's the quit command. Oops. There's the quit command. To get to it, you have to hit the second key. Second mode will give you to quit. And all that does is take you back to your home screen. All right, now we have matrix A in there, but we don't have matrix B. All right, however, we don't really need to have matrix B because the calculator will calculate every single one of these expected values for us. But we first have to have matrix A into the calculator. Now let's go and run the chi-squared test. This is always the same. The observed values are going to be what we entered into matrix A, and then the expected value, you could calculate them all for yourself and enter them all in there if you'd like, but when you run this test, it would just replace everything that you've entered into matrix B with the actual expected values, with your same values that you calculated. All right, so we're going to go run the test, stat, over to tests, and then all the way down. Okay, it's option C, chi-squared test. Showed you this earlier. There's no changes that you need to make to any of these. Just come down and calculate. And then from there, you write down your test statistic, which is a chi-squared test statistic, 21.357. And then the p-value comes next. And you know that p cannot be 2.6. There's the degrees of freedom that we calculated here. P is a number between 0 and 1. So make sure you read this p-value from right to left. This means you need to move that decimal place 4 places to the left. Now, it was able to calculate this even though we didn't enter in B, the matrix B. Turns out that matrix B is just calculated with row totals and column totals divided by the total. And if you give it the matrix A, it can calculate all these things and do it for you. And that is in fact what it did. And so let me go to the matrix menu again. If you want to see that matrix B, let's go to matrix. And then we don't want to edit anything right now. We just want to go take a look at matrix B. So I'm going to go down 1, hit enter. So that matrix B goes to the home screen, and then I'm going to hit enter. And you don't see it all here because it gives you so many decimal places of accuracy. But what you probably can see is the very first one that we calculated, that one right there. And these also are the expected values. And if you scroll over to the right, you can see the others. So it took me a long time to do this, but basically, you know, you enter in matrix A, and then you calculate the test statistic and then the p-value. Okay, now we're getting short on time, so I thought what I would do is just maybe give you a couple of details in the notes. Okay, here's the expected values. In the notes, I kind of write out in a little bit a different way how you would enter in that matrix into A and then calculate the test statistic and the p-value. The other thing that you'll see in your notes is how you would calculate by hand the test statistic for chi-squared. Here's our original A. Here are the values that the calculator calculates for matrix B, the expected values. And then what you do is you take this number, subtract this number, square it, and then divide by the expected value. So these are going to be the same. And you do it for every one of the 9 cells. For each of the 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 cells, you're going to have this complicated fraction that looks like the difference of 2 things squared divided by another thing. Then if you add up all these numbers, that's what the sum means, you get the test statistic. So this test statistic calculating by hand is exactly the same test statistic that we calculated. Well, I'm not going to be able to see it, but 21.357, 21.36 there. So exactly the same. And then I just wrote down the conditional proportions here, and then some things that you should notice when you look at those two. But these will be included in the notes if you want to get a little bit more detail about how that test statistic is calculated using the observed and the expected values. It's there. So